Welcome to this explainer. Okay, today we're looking at a genuinely fascinating new development in the generative AI space that's dropping tomorrow, July 16th, 2026. We're talking about NVIDIA's Nemotron-3 Embed-1 NVFP4. Basically, think of this model as having absolute heavyweight capabilities, but packed into this highly efficient, really lightweight footprint. If you're out there building Retrieval-Augmented Generation, RAG applications, understanding the nuts and bolts of this model could literally change how you approach scaling your systems. It offers this really compelling blend of crazy speed and laser precision.
Okay, let's dive into this. Here is the highly logical roadmap we're going to explore today. 1. Multilingual embedding champion. 2. The power of quantization. 3. Training and evaluation. 4. Mastering vLLM deployment. And 5. Ethics, privacy, and safety. Listen, if you're an AI developer, an engineer, or maybe a product manager, you know this struggle all too well. Building a robust Q&A application over just a massive text corpus is incredibly demanding. When we start talking about huge context windows and global queries, well, that usually means astronomical compute costs, right? It just becomes this massive bottleneck for growth. So the core question we always come back to is, how do you scale an intelligent application globally without burning through your entire infrastructure budget just to process the queries? So the crucial point is that this model was engineered specifically to answer that exact problem. Nemotron-3 Embed 1B NVFP4 is a quantized text embedding model, and it's optimized explicitly for multilingual question-answering retrieval using the NVIDIA Model Optimizer. It's built to give you the performance of a massive, compute-hungry, dense model, but with the agility of a lightweight one. It totally bridges the gap between high-end retrieval accuracy and the real-world practical reality of, limited GPU memory and strict deployment budgets.
Section 1. Multilingual Embedding Champion.
Let's look under the hood at the DNA of this model. It uses a transformer architecture, specifically leveraging a pruned encoder that's based on the Minstrel 3b instruct model. It sits at a really highly optimized 1.14 billion parameters with a hidden size of 2048. What this actually means for us in plain English is that it takes your input text and encodes it into dense 2048 dimensional embedding vectors. That deep dimensionality allows the model to capture incredibly nuanced semantic meaning. So when a user asks a complicated question, the model understands the underlying intent perfectly. It's condensed, it's lightning fast, and yet it's deeply complex all at once.
But, it's not just smart, it's worldly. This model has been rigorously evaluated across 34 distinct languages. We're talking Arabic, Bengali, Chinese, Finnish, Hindi, Swahili, Thai, Ukrainian, Vietnamese. The list goes on. Normally, building a globally accessible app means managing multiple language-specific models, which is, let's be honest, a total integration nightmare. But having a single model that natively understands and retrieves across this huge linguistic spectrum, that means it's ready for commercial, worldwide deployment on day one.
Section 2. The power of quantization.
Okay, let's use a suitcase analogy here to explain this quantization process. Moving from the standard 16-bit precision to this NVFP4 format, it's kind of like taking a massive, overflowing trunk of clothes and just brilliantly vacuum sealing it. You are packing the exact same amount of meaning and performance into a much smaller, much lighter carry-on bag. It takes up a fraction of the space and memory footprint on your GPUs. This compression is exactly what transforms a conceptually powerful model into a deployable reality for teams that, don't just have infinite server racks lying around. And this brilliantly illustrates how they pulled it off. To pack that suitcase so perfectly, NVIDIA applied post-training quantization specifically to the weights and activations of the linear layers. But, as we know, compressing a model can sometimes cause it to lose its sharpness, right? To fix that, they used Quantization-Aware Distillation, or QAD, on a highly targeted 20,000 sample data mix. This distillation process acts almost like a corrective lens, recovering the model's accuracy. It was absolutely vital to ensure the model didn't lose its edge or start hallucinating when handling those incredibly long input sequences.
Section 3. Training and Evaluation Results. Now, what's really interesting about this slide is that this is the real climax of our story against the RTEB benchmark. That's the Retrieval Embedding benchmark designed for actual real-world applications. The original BF16 model scored a 72.38. The newly quantized NVFP4 model scored a 72.00. Think about that for a second. The model drastically shrinks in compute size, dramatically lowering your operational costs, but it only loses a microscopic 0.38 points in retrieval accuracy. That is just a masterful trade-off for any engineering team looking to scale. You're getting the operational agility of a tiny model, but with the reasoning capability of a massive one.
Section 4. Mastering vLLM Deployment.
If you're actively building a global Q&A app right now, this setup flow is going to save you hours of debugging. Step 1. You absolutely must use the explicitly tested vLLM version 25.0. Older versions have known issues with this NVFP4 family, so making sure you have version parity is super crucial. Step 2. Start your server. The real beauty of this implementation is that the tested vLLM builds read the checkpoint metadata directly. It actually handles the NVFP4 flag automatically for you, so you don't need to pass any complex quantization arguments. Step 3. Simply route your retrieval requests to the standard/v2/embed endpoint and boom, you are up and running.
There's a massive number we really need to highlight here. 32,768. That is the maximum sequence length limit for tokens in this model. For an embedding model, that is just an incredible amount of context. You aren't just embedding a single paragraph anymore. You can embed massive legal documents, long medical transcripts, huge code bases, all at once in a single pass. This fundamentally alters how you segment and chunk your data before vectorization, because it allows you to preserve the broader context of entire documents.
But with that immense context window comes a pretty critical strategy warning for developers. Because this model can handle up to 32,000 tokens, you have to manually tune your coup de graph capture. You need to pad to your longest intended request. If you just let the system automatically capture up to the full 32K context default, your server startup time could lag for tens of minutes as it tries to build out those massive memory graphs. Instead, what you want to do is set a conservative maximum capture size, like maybe 4,096 or 8,192. Or pass a sparse capture size list. Doing that drops your cold start bottleneck down to just about 1 minute.
Actually, one more essential pro tip for your developer pipeline. When you boot up your server, the Transformers configuration parser is going to throw a warning at you about a field called apply_yarn_scaling. Do not panic. And more importantly, do not remove it from your config.json file. It's just the temporary vLLM compatibility field, and it's designed specifically to preserve the intended rotary position embedding behavior for those incredibly long 32K contexts. It's just a quirk of the current ecosystem. So just ignore the warning and keep building.
Let's move to Section 5, Ethics, Privacy, and Safety.
So before you launch, let's quickly review what you need to provision. You'll be running on a Linux environment, and it's supported broadly across modern NVIDIA microarchitectures. That includes Ampere, Blackwell, Hopper, and Lovelace. As for licensing, the model itself falls under the Open MDW License Agreement version 1.1, while the underlying base network it was built upon maintains an Apache 2.0 license. Ultimately, this provides a really clear, open-weight framework that is totally primed and ready for your commercial integration.
Well, there we have it. We've explored the architecture, we unpacked the sheer efficiency of NVFP4 quantization, and we opened up the vLLM deployment playbook. You now have this incredible featherweight model that punches so far above its weight class, delivering massive 32,000 token context windows across 34 distinct languages, all without destroying your infrastructure budget. So with compute costs no longer holding back your retrieval scale, what massive multilingual corpus are you going to conquer first?